This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. The Artemis 1 mission took some rather unusual things into lunar orbit. First, there were the zero-gravity indicators, a plush Snoopy and a plush Shaun the Sheep. There were also the Silver Snoopy Award pins that were taken to honor workforce members who made significant strides in mission safety and in human spaceflight. 4 Lego figures that include Kate, Kyle, Julia, and Sebastian from the Build to Launch, a STEAM exploration series that includes 10 weeks of digital content about space and science on the LEGO Education website. Parents, educators, and students can use the minifigures to learn more about STEAM, which stands for Science, Technology, Engineering, Art, and Mathematics. Now, in addition to the, maybe you call them toys, there are 3 simulated astronauts, or Moonikins, that will show how risk to astronauts comes from moving outside the Van Allen radiation belt that shields Earth's lower orbits from radiation. The Moonikins are named Arturo Campos after an engineer who was key to solving the problem of bringing 3 astronauts home safely from the moon after a series of critical problems beset Apollo 13, and also Helga and Zohar, 2 mannequin torsos from the German Space Agency, each fitted with 5,600 sensors to measure radiation. Zohar also wore an AstroRad radiation protection vest. Now here are Jacob Bleacher, NASA Chief Exploration Scientist, Shamila Bhattacharya, NASA's Program Scientist for Space Biology, Renee Cox, SME Payload Integration Space Launch System, and Lisa Callahan, VP and GM Lockheed Martin Commercial Civil Space, to explain some of the Cubesats and other science demonstrations aboard Artemis 1.
Artemis 1 is paving the way for us to explore deeper and deeper into space.
I think Artemis 1 is significant on so many levels. It is a new frontier to do science.
So the primary objective is to test the Orion spacecraft integrated with a space launch system.
And it is designed to carry out the boldest of the bold missions.
But it's more than just learning how to travel in space. We're taking a lot of cool science along with us on this first mission to the moon.
So as NASA plans to go back to the surface of the moon and then onto Mars,
we want to spend more time there, and that's riskier business. So the more we learn about the moon itself and the environment where we'll be operating, the better we can prepare. We have 10 Cubesats we call secondary payloads, which are small scientific spacecraft of their own that will each be conducting their own scientific mission.
All of these payloads in some form or fashion will help us going forward. They are going to be studying the moon.
And they're going to help us understand what is the moon made out of, what types of rocks, what types of regolith, what types of ice, what's mixed in with water that might be present.
One of them actually is going to attempt to land on the moon. They're going to be studying the sun.
Understanding and studying the space environment or the space weather.
Some different propulsion systems. These novel ideas will ultimately turn into the technology and the systems that we want to use going forward.
There's a lot of cool things going on between all these Cubesats that make up our secondary payloads. Additionally, inside the Orion, we'll be flying an experiment to study space biology.
Space biology is where we study the underlying changes that Earth-based biological systems undergo when they're in space.
Or basically, how does life respond to the space environment?
The level of ionizing radiation that you experience when you go beyond the Van Allen belt, so you go beyond the protective magnetic sphere that we have around us, you then get exposed to higher levels of ionizing radiation. So we are flying several space biology experiments.
We will take a series of materials,
plant seeds, fungi, the yeast cell, algae,
and ride along the trip. And then when it comes home, we can analyze how they responded to that environment.
This research will help us thrive in space. It will help us to go further and stay there longer.
In addition to space biology, we'll be learning about how to make astronauts more effective in the Orion in the future. An example of that is something called the Callisto Technology Demonstration.
Lockheed Martin built the Orion spacecraft for NASA, and we'll be flying a secondary payload that's a demonstration payload called Callisto. So we took the technology from Amazon for Alexa and the WebEx technology from Cisco, and so we built a digital assistant, if you will, the custom space-qualified Alexa.
Alexa, how does the life support system work?
Orion's life support system is the environmental control and life support system oracles.
And so this payload is the demonstration mission to show how astronauts in the future could use this technology as an innovative user interface.
So there you have it. I hope you agree with me. This is exciting.
I am just over the moon excited for the Artemis 1 launch.
The science we'll conduct on Artemis 1 lays the groundwork to ensure that we can safely conduct scientific activities at the moon with our astronauts going forward. This really is the stepping stone for us as we take that next giant leap in space exploration.
The 10 Cubesats they talked about were packed into the SLS upper stage of the rocket. 7 of those Cubesats are still functional and proceeding along their mission, and 3 appear to have been lost. The Lunar Ice Cube Cubesat will look for water on the moon and map resources for future explorers to consult. The effect of space radiation on yeast cells will be qualified in the BioSentinel Cubesat's orbit around the Sun. And the Equilibrium Lunar Earth Point 6U spacecraft, or Equius, from JAXA, is designed to explore radiation in an orbit between the Earth and the Moon. The Cubesat has a novel water propulsion or steam system that allows it to minimize conventional fuel usage. So the Artemis 1 had an amazing amount of scientific and fun science experiments aboard. Can hardly wait to see how a lot of it turns out. On December 11th, many of those scientific experiments will return to Earth with the Orion capsule splashdown, and some of them have remained in orbit around the moon. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
On Sunday, December the 11th, the Orion spacecraft will come blazing through the atmosphere at 24,500 miles per hour. Join Dawn Meyer, Space Coast News Editor, and me, David Denault, and watch the splashdown live with About Space Today at 12:15 p.m. Eastern Time. Don't miss the last test for Orion, the re-entry on the new heat shield. Splashdown is planned for the Pacific off the coast from the San Diego Naval Base on Sunday, December the 11th. Coverage begins at 12:15 Eastern Time. On our YouTube channel, tinyurl.com/AboutSpaceTodayYT. Once again, our YouTube channel, it's tinyurl.com/AboutSpaceTodayYT. The Splashdown of Orion.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.